Okay, so I think it's probably time to get started. This is the session basically in honour of Vic Barnett, who very sadly died on February the 16th of this year. Many of us remember him extremely fondly, and many of us will know him professionally and also personally. He had a long and very distinguished academic career and was very, very active in the RSS in a number of different roles, including being the Honorary Treasurer, Editor of Series C, Chairman of the General Applications Section, and he was awarded the Chambers Medal for his contributions to the RSS. As I said, he had a long and very distinguished academic career. He held positions in Bath, Sheffield, Rothamsted, Nottingham Trent. But I really came to know him directly through his instrumental role in the creation of the Environmental Statistics section of the RSS, which is one of the sponsoring sections along with the General Application section for this particular session in the conference. As well as that, he basically was the founding father of Spruce, which was statistics and public resources, utilities, and a few other things. I can never remember the complete title. But he really in a sense, was very much in the forefront of creating, I think, a respect for the whole kind of discipline of environmental statistics. He worked with a wide variety of people in a wide variety of different areas, and the speakers that we have this afternoon have had long and a very sort of successful, as I said, both academic and personal collaborations with Vic. So it's really a great pleasure for me to chair this particular session. So we've got three speakers. I'm going to be a very fierce chairman because Vic could also be a very fierce chairman. He stood for no nonsense. So our first speaker is Tony O'Hagan from the University of Sheffield, and he and Vic worked for a number of years on the whole issue around environmental regulations and policy.
Thank you. It's a great pleasure to be involved in this session. So without further ado, since I'm going to be so fiercely managed, let's begin. So I knew Vic primarily when I was at Nottingham University, and when he had moved to Rothamsted, and he was looking for some more academic contact to keep himself alive in certain aspects. So this is the only picture I could find of Vic. There are very few out there on the web, and I don't have any personally. But that's Vic as I recall him, although a little later, and always that kind of cheerful-looking chappie. He's, of course, as we've just heard, remembered very much for his promotion of environmental statistics, but many other things. But it's how I was mostly involved with him. In 1995, he was invited, and this was a notable honour for him, invited by the Royal Commission on Environmental Pollution to prepare a report from them. They were interested in how much uncertainty influenced the setting of standards. So the title they were asking for was Uncertainty and Variability in the Setting of Environmental Standards. And whenever you hear that uncertainty and variability, you really appreciate straight away that people are thinking about variability, uncertainty in a very wide sense. They are allowing for uncertainty due to lack of knowledge, as well as the variability that's inherent in the environment, the sort of randomness. So he kindly asked me to help him with this, and we complemented each other rather well, I say there, because Vic was extraordinarily good at digging out references and researching the literature, something which I've always been awful at. My own approach to these things was I would write papers and wait for the referees to tell me what I should be citing. And if it had been done before, too bad. But the other thing that we complemented each other on was that I was quite good at coming up with weird ideas and new ideas that other people hadn't had, and I'd always traded on that by not having to do my own research for the literature. So we worked together on this. We did our own bits, and the result was a report which was deemed to be good enough to actually be published in its own right. And this was quite unusual for the Royal Commission. They prepared their own reports. Ours was an input to their report, but our part was deemed worth publishing in its own right. It was a very rewarding experience to work with Vic on that. I respected him enormously, and that's kind of my connection through him there meant that this was a natural subject to talk about here. It's about regulation and standards, because I've come across them in a number of different guises myself, and I think it can be helpful for people to realise just how big a field this is and how diverse it can be. So my outline deals with a number of those things. So that I'll begin by dealing with a project in the nuclear industry, which will sort of set the scene for the issues that we'll be talking about. And then I'm going to run through some sort of generic features that I think that highlights. And then there'll be a bunch of different applications that I've come across that will show the diversity that we can meet within this. So, Canadian Nuclear Safety Commission, they are the regulators of the nuclear industry in Canada. Canada is interesting from the nuclear point of view. They have their own kind of reactor that they developed and which is used exclusively in Canada and in one or two other countries that they've sold the technology to. And this is called the CANDU reactor. CAN is for Canadian. I think it's deuterium uranium, the D and the U. Anyway, they want to set a safety trip for what they call a loss of regulation event. This is when the core is heating up relatively slowly. It might happen over seconds even, or certainly minutes. So it's that kind of time scale. It's not a sudden explosive heating up, but it's when they don't know why, they're just not managing it the way they thought they were. And this trip needs to be there because we may not spot it through human intervention. So sensors in this core detect a flux at various points in the core, and when their readings together reach a certain level, this trip should be fired. The trip is hardwired at a particular level. Now, sorry, uncertainty and variation. Variation here. The hottest point in the reactor isn't always in the same place. It's going to be in the middle somewhere where all the flux is concentrated. But, oh, thank you so much. But a feature of these reactors, and it's unique to these CANDU reactors, is that they refuel them on the fly. So while the reactor's operating, they're able to pull out a fuel rod which is spent and insert a new, fresh one with new elements in it. As a result, the balance of the heat in the reactor is constantly changing. As they put in fuel rods in one area, it's going to heat up in that area, and then as they decay, and they decay faster when they're new, that balance keeps changing. So there's variability about the extent to which the sensors, which are in fixed locations, are actually measuring the heat in the hottest part of the core. So they want this trip to operate early enough, but they can't be sure it'll always operate early enough because this random variation. So they set a point where they think it's unlikely that they will be tripping too late. And there's a certain amount of leeway anyway. Okay, so they want to set it so it will operate 95% of the time, or even more often. I think they're now thinking 99% of the time. So they want to set a point where the distribution, this red curve, of the point at which they ought to trip it now, if not before, at the 5% point of that distribution down here, so that there's only a 5% probability that they ought to have tripped earlier. But they don't know where that point is because this is an unknown distribution. It has unknown parameters. And so they've got uncertainty about the parameters. They've got data, and so they need to do statistical estimation of those parameters. And so here's a probability distribution for where that 5% point would be, and they choose the highest, the upper 95% point of that. So this is what I learned as a student. It's called a tolerance limit in frequentist statistics. I almost never hear that term these days. It may still be used, but it's a useful idea. And it nicely combines the variability here, the randomness, with the uncertainty, the epistemic part over here. So that sort of illustrates what I want to talk about generally in regulation. This is a situation, as in nearly all these, where there's one regulator, but there's many companies that they're regulating. So all the different operators of nuclear power stations in Canada. The regulator sets the standards and oversees and checks compliance with those. And the companies need to demonstrate to the regulator that they're meeting those standards. The regulators aren't usually prescriptive about the methods that are to be used. There's nearly always uncertainty out there and randomness, and statistics is very often required to be used in order to come up with appropriate submissions to the regulator. But the regulator doesn't usually say exactly what methods you have to use. So the regulator also needs to be able to assess whether sensible methods have been used. Both uncertainty and variability are nearly always present there in various different guises, so statisticians are needed. And typically they work for either the regulator or the regulated, or both. And in this particular instance, I was working for the regulator, but there were statisticians on the other side who were working for the companies proposing methods that I was being asked to check. Okay, so here's just some of the regulators that are around, and I didn't even know of all of these. Solicitors Regulation Authorities, anyone know about them? This is just a sample of all the regulatory bodies that exist in this country. So there's a lot of these people around. So my next example is the European Medicines Agency, which for some reason is called EMEA. I'm not actually sure why. Anyway, they're the European counterpart of what in America is called the FDA, the Food and Drugs Administration. And they verify whether people are allowed to, or decide whether people are allowed to market a drug and put it on the market and sell it. And there are huge numbers of statisticians working this. I wouldn't be at all surprised if some of you are already working for the pharmaceutical industry, been involved with the pharmaceutical industry, etc. A lot of them around. It's one of the biggest employers of statisticians. And they work for the pharmaceutical industry, but they also work for the regulators. And the standard is nearly always this frequentist one of getting a statistically significant effect in a confirmatory, as they call it, phase 3 trial. You have this strange thing, which is a confirmatory trial. You're confirming your suspicion that something works. You're not allowed to use evidence that it works that comes before the trial. You're only allowed to use the trial itself, which again is really strange to me. And when you do this, you can prove anything that is deemed to be beneficial to the patients. As long as your drug does something that could be useful, you're allowed to sell it. Okay, even if it's really quite trivial and just only peripheral to the disease. Of course, it shouldn't have unacceptable side effects as well. That's important. There is an increasing shift in that industry towards Bayesian methods, which of course I'm pleased to see because that's my interest. And it's partly driven by the fact that developing drugs is getting so expensive that the companies are being pushed to do more and more and more to prove their drugs work, and yet the payoffs are just not there. So somebody's got to decide somewhere along the line that you can use more evidence. You can bring some other evidence in, and that's where Bayesian methods come in. A related issue, cost effectiveness. Now, this is regulated differently in this country, and in many countries it's not regulated formally at all. But here we have NICE. It used to be called the National Institute of Clinical Excellence when it was founded, and that's where the acronym comes from. It's since changed its name twice, with an H in the middle, and they did toy with putting the H into the acronym and then decided that it was unpronounceable and everybody still called it NICE, so they've left it as being called NICE. Anyway, they have different statistical challenges because they don't have to say this drug does something which could be useful. They actually have to say this drug does something which, for the cost of it, is doing enough use to our patients that the NHS should pay for it. So they're looking at cost effectiveness. And when it comes to that, they've got very different statistical issues because clinical trials are designed to prove the old style thing, that this does something, at least to some people in some context. So we'll set up a trial with very carefully regulated conditions, very carefully chosen patients, and show that for some people this works. Well, the NHS wants to know if we apply it in hospital conditions or in GP conditions to any patient who's got this disease, will it do something useful? Will it help them enough for what we're paying for? And they have to then start synthesizing all sorts of evidence to supplement what they get from clinical trials, which makes them intrinsically Bayesian. Here's an example I worked on, multiple sclerosis, way back now. So there were new drugs coming in. They were the first drugs which claimed to actually help attack the disease rather than just make people with MS feel better. They were supposed to be helping to stop relapses or reduce the number of relapses that patients have. A relapse in MS is when suddenly you feel really bad and everything gets worse for a while. But you recover, typically in about a month or a month and a half, something like that. You get back to where you were, and nobody quite understands what these relapses are and how they're related to the progression of the disease. But to show that you don't have relapses or you have fewer relapses is not something the NHS is going to pay a lot of money for. Because these people, okay, they feel bad for a while, but they were feeling pretty bad anyway. They feel a lot worse for a while, and then they recover. And if that was actually also slowing down the progression of the disease, now this is worth paying for. Because people are now going to get this benefit in an extended way, longer life, longer good life, and so on. So there's a really interesting problem there, because there actually was some evidence available that it did slow down the progression of the disease, but the companies have never made anything of that, because they didn't have to get approval to license the drug if they simply showed it reduced relapses. So that was a very interesting example where evidence was brought in from various different sources. Okay, I need to move on. Asset management planning, completely different area, moving into engineering now. And a company like, for instance, a water company, these people are digging up water mains and replacing them. Companies have large quantities of assets. These companies like water companies, train companies, gas companies, even nuclear power distribution companies, loads of these assets, many of them underground or inaccessible. And so they wanted to know, they were required to know what their capital investment need was over a 20-year horizon. And they had to actually try and think, well, which of our pipes will need work? What kind of work? And they weren't going to dig up all those sewers to find it out. So this happened in privatisation. In 1989, the 10 regional water authorities were privatised. And they were first required to do this planning at that stage. And it was quite high profile then, because if they came up with a plan which said things were really bad and they needed lots of money, they might not get all that money, and it might actually limit their ability to sell on the stock market. Actually launching the companies was their big priority at the time. So the regulator was created, Ofwat, and he demanded that they estimate things with 90% intervals. This was because they were advised by some statistician that they should ask for this, which was good for statisticians, because a lot of us then on the other side of the fence, working with the companies, had to produce these estimates. Loads of them were produced, but unfortunately they reduced this need for producing these intervals, measures of uncertainty over time, because the regulator didn't really know what he was going to do with them. I mean, people don't actually understand what to do with uncertainty when you tell them about it, do they? And there's a great need for education there, but it wasn't happening. And so they basically moved to the situation where they said the companies need to know the answers. And we don't have any uncertainty in there, do we? So, and of course, a lot of other things happened. Expertise was lost between rounds. It happens every 5 years. 5 years is a long time for a company like that. As soon as you've funneled all this energy into producing the report, you've got a big team you've built to do that, immediately those teams are disbanded, sent to other places. Companies does one of it every 3 years, huge reorganisations, and they're all lost. And next time you come 5 years later and they're rebuilding a team, hardly any of those people are left that remember anything. That's very typical, very sad. Anyway, I must move on, because I'm going to get the flag from over there. Governments themselves are often regulating things more or less directly, and sometimes they set up things like Ofwat as separate bodies to do it. Sometimes they set up people to advise them on how to do it and setting the standards and so on. Like this Royal Commission, that was a body created by government to advise it on how it should handle these issues. It then proceeded to set up regulatory systems on that. So here are just 3 examples of that. The Environment Agency, or as it now is, it was something else at the time, there was this proposal to bury nuclear waste at Sellafield. And UK Nirex was the company that was proposing this low-level nuclear waste repository deep underground. 10 years of research and planning went into this from NIREX, but not only from NIREX, but also from the other side. The whatever the body was at the time, it became the Environment Agency. DEFRA, that's right. So DEFRA actually were developing all, in parallel to NIREX, developing their own methodology to check what NIREX was doing. And so massive work was involved, and it was just suddenly rejected by the government or by a planning officer at some point. Said, I don't want to listen to any more, I've had enough of this, we're not going to do it. So this sort of thing happens all the time. You put all this work in and you quantify all the uncertainties carefully, and then people get totally fazed by the whole thing and say, I don't want any of that stuff. There actually is renewed interest in this idea again, and of course new controversy about it. Much more recently I've been working with these people, the European Food Safety Authority. They do risk assessments and advise the European Commission. So the European Commission sets up this body, EFSA, to do its calculations of risk and advise it on what are the most risky alternatives. But the EFSA doesn't make decisions, EFSA isn't regulating. It's the European Commission will do the regulating, will create the rules and the laws, as we know, many of them. But in response to this advice that they're getting. And these people do employ statisticians. There's a lot of uncertainty around these risk assessments. And in particular, in many cases, there's no data. A lot of the time when they're doing this, they're working on new emerging problems, new emerging pests and risks and diseases that are potentially going to affect our food. And they need to advise the European Commission to take action early enough to address these things and prevent them being a problem to Europe. So here's an example of this thing. This is an apple snail. And it's a very big snail, as you can see. It's a voracious snail, and it reproduces very rapidly as well, and will very quickly cause a lot of damage to wetlands. It's a water snail. It's come over from South America, I think, or possibly from Japan. I know they're not very close, but it's one of those two. But it's already in Europe, and they're wondering how big this pest is going to be for us. So they were eliciting lots of uncertainty from experts, or lots of estimates from experts about the conditions in Europe under which this thing would I guess, grow most a problem. So I was involved in advising these people on how to use expert judgment, how to elicit expert judgment. There's a lot of interest these days in doing that. Okay. So they want to move towards a proper quantification of uncertainty and do probabilistic risk assessment. Well, at least these people do, the methodology division do. The rest of them really are resisting that, but the methodology division is pushing hard on it, and it will happen. Finally, I get back to the environmental pollution with my last 5 minutes. This is what we were doing, Vic and I, back then in 95 or thereabouts. This is actually a graph from the report we produced. We're trying to understand how there's sort of generic framework of standard setting in here. So pollutants get into the environment somewhere. They reach a point where they might be causing a problem. They cause a problem, and then there is a disbenefit, I suppose, to somebody from that. If we can act, we might be able to reduce these problems and have a benefit instead at the end there. So, but there's cost to this. So it's cost versus benefit always that plays a role in these things. So we introduced the ideas of ideal and realisable standards. An ideal standard is a standard that you say, I think the environment should not have in it, say, this chemical to a larger extent than this. And of course you can't measure it, that perfect accuracy. It's an ideal that you want to achieve. Now, a realisable standard is one that you can actually achieve. You could say, we require you to do a test on the water, take 5 samples, and they should all have a level lower than this, and then it passes. Okay? That's clearly a realisable standard, but how does it relate to the ideal standard? How does that control the thing that you really want to work on? And so we sort of worked on this idea of a statistically verifiable ideal standard. Horrible title, but it's an ideal standard with a standard for how you statistically verify it. Not a simple but realizable standard, which is just a check on something that actually is not the thing you're interested in, but something which is formally linked to the ideal that you're interested in, and that you can show how statistically it achieves that control. And careful characterization or uncertainty and variability were through there everywhere. And Vic was very strong on this, that this was the purpose of our report. We had to make it clear where uncertainty was present in all of these things, where variability mattered, and how these two played their own complementary roles in influencing the answers. And this is where we came to on that. And I have no idea whether the Royal Commission ever did anything more with that, or whether this idea ever got anywhere out into the environment, if you like. The book didn't sell that many copies, so I don't know. It's long been out of print. But I will end there with that, with just a few general comments. I think it's an interesting area of work. Statisticians often do have an important role, very often with quite high impact. These can be quite high profile things. It can be very good for our profession. The fact that so many of them are working in the pharmaceutical industry has been good for our profession, even if so many of them are doing rather boring things in there. Many different models of working. I've tried to show you that in the examples I've given you. Statisticians can be working, if you like, inside regulation for the regulator, or they can be working outside for the regulated. And these are often opposed to each other. There's a conflict anyway between the poacher and the gamekeeper. And it's very interesting for the statisticians to debate with each other on either side of this fence, as I had to do with the Canadian thing. Both uncertainty and variability are commonly present there. Oh, I've got both twice. Bad sentence. Bayesian approaches are, of course, natural because you need them to handle the epistemic uncertainty. And, of course, that's my final message. And Vic was not against Bayesian methods. He wasn't very familiar with them, but he was very sympathetic to these things being used where appropriate. Which that's always what these people say, where appropriate. Everywhere they're appropriate. But anyway, that's it, I think. Thank you very much.